Hello and welcome to this session on sorting in Python. Sorting is the most important algorithm which you might end up implementing in any programming language. Today we are going to talk about a couple of sorting algorithms which you can implement in Python in an effective manner. Now let's see what's in it for us today. We will discuss what is sorting in Python, what is the importance of sorting. We will discuss different sorting algorithms like bubble sort, insertion sort, merge sort, and quick sort with examples. What is sorting? Sorting refers to arranging available data in a particular format. So typically, when you have data in a non-sorted order, generally there is a requirement in any algorithm where you would require the data to be organized either in ascending or descending order. So if you take an example which is there available on the presentation, here you have a list L1 where you have random numbers which are unsorted, and then you have a sorted array which is in descending order, means highest number first and the lowest later. So generally any algorithm which you implement for sorting provides you a organized sorted list either in descending or ascending order. Now, why is sorting important? Now, you must have seen practically in your day-to-day life, whenever you are navigating through a website or through an application, you generally tend to or you want to see data in a sorted order, either alphabetically or numerically. It makes search faster and easier, right? It becomes easy to search an item when if it is sorted alphabetically. Sorting is also used to represent data in more readable format. So it allows you to read the data which is sorted easily. It helps locate various patterns in the data. So for example, if you have an alphabetically sorted data, then you can easily compare if there is a difference in pattern in the data which is lying in an Excel sheet or which is shared with you in any other data format. Also, and another important point is duplicate values. You can easily find out if there is an occurrence of a duplicate value when the data is provided to you in a sorted fashion. So all the basic utilities, standalone utilities, applications like Microsoft Excel or other utilities provide you basic functionality of sorting of data alphabetically or numerically. Now, Python has a built-in sorting method which is called as sorted, and it gives you a data in ascending order. Whatever input you provide, the list, it will give you data in ascending order. And Python uses a time series sorting algorithm inbuilt to perform this sorting. So let's take a look of the inbuilt sorting algorithm which we are going to show you on my Jupyter notebook. So it's going to be very straightforward. What we are going to do is we're going to create a list and just invoke the list.sort method and print it. And just with one line of function call, our list is sorted in ascending order 12, 15, 27, 33, 62. Now with this inbuilt function, if you want to change the sorting order, right, you want to reverse it in descending order, you just have to pass a parameter saying reverse equal to true and print the list. So if you observe, now you have your output in the descending order. So this is an inbuilt function, the sorted method, but we are here to discuss custom sorting algorithm, and we will start with bubble sort. Now, what is bubble sort? In bubble sort algorithm, the first element is compared with the adjacent element, and if the adjacent element is smaller than the first element, the elements are swapped. Basically, bubble sort is a sorting algorithm that compares two adjacent elements and swaps them until they are not in the intended order. So just like the movement of air bubbles in the water that rise up to the surface, each element of the array move to the end in each iteration. Therefore, it is called a bubble sort. It is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in wrong order. So we have to remember the point that the elements in the array are swapped till the time the intended order is reached and each element has reached to the last iteration. So we will see this with an example. Now here you have a sample list which has unsorted data 9864. Now according to the bubble sort algorithm, what it will do is, first it will start from the 0th element and compare it with its next adjacent element 8. Now in this scenario 8 is smaller than 9, so therefore we will swap it. So 8 and 9 will get swapped and now you have 8964. Now again 9 will be compared with its adjacent 6 and now 6 is smaller than 9, it will be swapped. Coming down, 9 now compared with 4, 4 is smaller than 9, it will be swapped. So till this point what has happened is 9 has been compared and with each of its adjacent element, and in this iteration now 9 is at its correct place, it's at its last place. Now we don't need to go to this iteration again, we will only go till the second last iteration. So now we will start from the beginning. We will compare 8 with 6, okay, and 6 is smaller than 8, we will swap. So now your output is 6849. Again 8 is compared with 4, 4 is smaller than 8, it is swapped. Now we will not go further because now we know 9 is at its correct position, 8 is at its correct position. Now only we need to do one iteration of comparison between 6 and 4. Now 4 is less than 6, we swap, and this is the final output of 4689. So all the iterations depend on the size of the list, but in bubble sort the whole goal is that you keep it iterating till the time each and every element is compared with its adjacent element. Now let's write a piece of code in Jupyter in order to compare our algo what we have discussed. Okay, so what I'll do is I'll just create a list of elements. Now this is the list which I showed in my example and I want to sort it. So I'll create a function bubble sort and I'll capture the length of the array. Now I need two loops, one loop which will run n number of times the length of the array. So I'll create a loop okay, and then there will be a second iteration which will run from the first element of the array to the last element, okay, one less than the last element till the time I have placed my sorted last element in the array. So I'll show you that. Now in my example I'll print my j iterator and the adjacent element to it. Okay, now what we have to do is we just have to write now the condition that if the element to which my inner loop is pointing is greater than the next element, then we will swap. Now in Python, there is a very easy way to write the swap code. You are swapping the two adjacent elements with each other. So you just have to write this line. And now this piece of code will place at j position the adjacent element of j plus 1, and at the adjacent element it will put the previous element. Now just to show you, I'll print the array at unsorted and sorted level. So I'll print the array over here and here so that you can easily understand how the array has been sorted. Okay, so now you have a one loop which is running for the number of times the length of the array, and then the inner loop which is running from every time from the first element to the one less element length. Okay, now let me run this. Okay, okay, so now what we have done is, now I'll explain my example. Okay, so what we have done is we have 9864. Okay, now the length of this array is 1 2 3 4. So the element, the length will be n, will be 4. My outer loop will run from 0 to 4, from 4 times 1 2 3 4, and now my inner loop j will run 6 times, and I'll show you how. So now first j at 0 and its adjacent element is at 1. So what we are doing is we are comparing 9 with 8, and 8 is smaller than 9, 9 is greater than 8, we are swapping it. So now this is my unsorted array and this is my sorted array. So 9 and 8 are swapped, you have 8 9 6 4. Now I move ahead, j is incremented to 1 and the adjacent element is incremented to 2. So now I am comparing 9 with 6. As 6 is smaller than 9, I swap it. So now my next set or array is 8694. Now I go to j2 and adjacent 3. So 9 and 4. I compare 9 and 4. 4 is smaller than 9. I swap it. Now till this iteration, now 9 has reached its correct position. Now I'll go back again and start my iteration from J0 back again and go only till this element 4. So again I am comparing 8 with 6. 6 is smaller, I swap. Then now I am comparing 8 with 4. 4 is smaller, I swap. Now 8 has reached its correct position. Again now I am going back to 0 and will only go to the point of 4. I compare 6 and 4, 4 is smaller, and I get my sorted list of 4, 6, 8, 9. Now if you observe, the number of iterations which have happened are 1, 2, 3, 4, 5, 6. It's because 9 has traversed 3 times, 8 has traversed 2 times, and 6 has traversed 1 time. 3 plus 2 plus 1, 6 iterations. So that's how you get those iterations. So this was an example of bubble sort. Now let's take example of insertion sort. Now what is insertion sort? Let's talk about that. Insertion sort places a given element at the right position in a sorted list. So in the beginning, we compare the first two elements and sort them by comparing them. Now let me show you what I mean by insertion sort. Now in insertion sort, whatever list you have, the first element is always considered to be sorted and the rest of the other elements are assumed to be unsorted. So you start your comparison of first element with its adjacent element, right? Now just to simplify things, insertion sort is like playing cards, where like you shuffle the cards and sort your cards, playing cards in your hand. It's just like that. Okay, so the array is virtually split into sorted and unsorted parts. Values from the unsorted parts are picked and placed at the correct position in the sorted part. So now in our example, our sorted part is 8 and unsorted is 4, 6 and 9. Now in the second iteration, we will compare 4 with 8. Now 4 is smaller than 8. We will put it before 8, and now we have sorted list of 4 and 8 and unsorted list of 6 and 9. Now in the next iteration, we will compare 6 with 8. Okay. And if 6 is smaller than 8, we will insert it before 8. And also we will compare 6 with 4, but now 6 is greater than 4, we will not swap it. Now my list is 4, 6, 8, 9, and 4, 6, 8 is sorted and 9 is unsorted. Now again I'll compare 9 with 8 and it's already greater than 8. I don't need to swap it and I'll not go any further and I'll stop it over here. So that's how my sorted list will get created. So my final list is 4, 6, 8, 9, and we'll see that with an example. So now let's create our insertion sort logic. So in my example, I want to create an array 8, 4, 6, 9, 15, 12. And I want to create a function called insertion sort. Okay. Now it's pretty simple. You want to traverse through the entire length of the array, but you want to start from element 1, not from 0, because 8 is your sorted element. You are already considering it your sorted element. Now take a variable in which you capture the outer array, and now I'm putting a while loop with two conditions. One is definitely the one which I explained, that you compare the unsorted element with the sorted element, so the previous element, and you go till the point on the sorted side till the last element. You don't need to go beyond 0, right? You need to only traverse through the first element, which is as the 0th index. And if you then you of course put the swapping code. You swap the unsorted element with the sorted side, and you need to go. So from the right hand side, you are going towards the left hand side of the array, right? From right towards left. So that's why you need to decrease the number. Okay. So what are we doing over here? What we are doing is we are comparing 4 to with 8. Now if 8 is greater than 4, you swap, and you only go till the point you have index 0. Okay. Like now if 4 and 8 will get swapped, now 6 will come. 6 will compare itself with 8. It is smaller, it will swap. 6 will compare itself with 4 and it will stop over there. So let me show you. I'll put a print command so that it is easy to understand. So let me print the array over here and see. Okay, so what I've done is I have to print my array. Okay, So this is my original array 8, 4, 6, 9, 15, 12, 11. Now in first time I compare 4 with 8 and swap it. Then I compare 6 with 8. It's smaller, I swap it, but 6, and also compare 6 with 4, I don't swap it. Then I compare 9 with 8, it is not small, I don't swap it and I stop it over there. Then I compare 12 with 9, it is not small, I stop it over there. Then I compare 11 with 12, it is small, I swap it, right? And then of course 15, I compare with 12, I stop it because it's already bigger. So it is like you divide, you always follow the approach of sorted and unsorted like I presented, and you keep comparing with the unsorted side element with the sorted side element and keep moving towards the left hand side. So now let's discuss another sorting algorithm called merge sort. Now merge sort is a divide and conquer algorithm. So basically in merge sort, you first divide the list into equal parts and then sort the parts and unite them as a sorted list. So basically you split the list into halves and then keep halving them, reducing each half till the time there is a single element in each half, and then you start merging them back in a sorted fashion. So we will discuss this with an example over here. Now for an example, we have our list over here with unsorted numbers 8, 4, 6 and 9. Now as it is even number of items in this list, so they will get distributed into two equal halves. In the left half you have 8 and 4, and in the right half you have 6 and 9. Now again recursively you will split each half, the left half and the right half again, till the time you have single elements. So now you see 8 and 4 now again get split into individual element of 8, 4 and 6 and 9 into 6 and 9. Now you start merging the individual elements in a sorted fashion. So first you will compare 8 and 4. Now 4 is less than 8, so you swap and put 4 first and 8 at the second position. Similarly, when you compare 6 and 9, 9 is greater than 6, then the order of this particular set remains as is. 6 and 9 are taken into the new array. Now you have two merged halves which are in sorted order, 4 and 8 and 6 and 9. Now while merging, you compare the leftmost elements of each array. So first you will compare 4 and 6. So 4 and 6, now 6 is greater than 4, you place 4 and 6 at their correct positions. Now you compare now 8 with 9. Now 8 is the leftmost item in the array and 9 is the leftmost item in its own array, and both are in the sorted fashion. So that's why you put 8 and 9 at their relevant position, and this is your sorted output. So definitely we will take a look at the example with our implementation in Jupyter Notebook. Okay, so now let me take my list example which I had shown in the presentation, and I want to perform a merge sort on this list. Okay, so I'll create a function merge sort, and I'll start off with checking that the length of my list is greater than 1. If it is a single element, then I don't need any sorting. Now I'll find the midpoint of my list and take the left part of the array list and the right part of the list. So the convention which I am using is actually automatically taking, means that the list starts from 0 till the midpoint, and the list here will start from midpoint to the length of my list. It's the same convention. So you can keep 0 or not, it's up to you. And the length of my list I have the /2 means that if the list is of odd number, then it will divide by 2 and round it up to the nearest integer. So you will not get a decimal output. So you will get a integer rounded mid value. Now, after I have done this, I will recursively call the left array and the right array through this merge sort. So using this, I'll be able to get the split value of 8469, and with this recursions I will reach to the point where I'll get individual elements of 8, 4, 6 and 9. Okay. Now I have to iterate through the left array and the right array. So I'll create two variables which will help me iterate through left and right array, and I'm also initializing a variable which I'll keep as a counter for populating a new array which will comprise of my merged list. Okay. So now this is the logic. I will loop from left element from 0th index to the length of the left array and 0th index to the length of the right array, and I'll compare. If the left is less than equal to the right, it means I already have my value in the sorted order. I'll just add it to my merged array and put it at the kth position and increment my left array further, else I have to pick up the right array element. So if the left array is smaller and greater than right array, then I put it the left one in the merged list, or if the right one is smaller than the left one, then I put it in the merged list and increment my right list. Now while after this conditions are done, I increment my merged list incrementer. Okay, I move ahead. Now there could be a possibility that there might be some elements which might remain uncompared in the left list. Like for example, if this would have been an odd number of elements, then here would have been 3 and 2, then one element will remain uncompared. So then I need to iterate through the remaining left array and just put them in my merge list and increment I and k by 1. And same could be the possibility of the right array, that there might be some elements which might remain uncompared or unsorted in the right array. So I'll put them back in my merge list. So my list is my list which I am updating constantly. So now let me put some prints. When I'll run this code, I want to put some printouts so that I can explain where my list is. Now this is my merge sort and I'm gonna run this. Okay, so now what I have done, we had a list of 8496. So in the first recursion, the list got split into 8 and 4 and 9 and 6. Okay. Now, okay, sorry, let me just make it similar, 8, 4 and 6, 9. Then in the second recursion, I have 8 as a single element, 4 as a single element, and in the third recursion, I have 6 as a single element and 9 as a single element. Now after that, this logic gets executed where I compare left and right elements and merge them. Okay, so now I compare 4 with 8 and 4 is less than 8. I swap it, move 4 to the left, common array, and then 8. Then in this case 6 and 9, they're already in the sorted fashion. I just move it into my common list, my list. And again now 4, 8 and 6 and 9 are compared. The leftmost element is 4 compared with 6. It's smaller. It is put it in the common list. 8 and 9 are smaller. It is put it in the common list, and you have the sorted array. So this is the idea behind a merge sort, where you have divided the list to the nth element, to the 0th element, and then you start merging it back by comparing the leftmost elements. Now let's take an example of another sorting algorithm called quicksort. Quicksort, like merge sort, is also a divide and conquer algorithm, but in a different way. In quicksort, first you choose a pivot element in the array, then store elements less than the pivot in the left subarray and greater than the pivot in the right subarray, and then keep doing this activity recursively for each subsequent left and right array which you have done. After that, we will call quicksort on the left subarray, and similarly we will call quicksort on the right subarray. So it's a recursive algorithm based on the choice of the pivot element which you have taken on the array. Generally, the pivot element is generally taken as the rightmost element of the array. Now let me try to explain quicksort with an example over here, and then we will look into the Python code. Now I have an array with 6 elements where my last element is my pivot. So now what I have to do is I have to create a left array where all the elements smaller than 34 should get aligned, and then I have to create a right array which should be having elements greater than 34. So in order to achieve that is the whole algorithm which you have to write. Now I have taken 2 pointers, the orange colors, and the one on the left hand side and one on the right hand side. This is I and this is J. Now what is the job of I pointer? The job of I pointer is to find the elements which are less than 34, and the J pointer is to find the elements which are greater than 34. Okay, so I will keep on shifting towards the right until and unless it finds an element greater than 34, and in case of J element it will shift towards the left until and unless it finds an element less than 34. Okay, so we will see that. Now I will start its journey from the 0th element always, and J will start its journey from the one element less than the pivot always. Okay, now in this example I is already pointing to a element which is greater than 34, but J is pointing to an element which is greater than 34, but it should move towards the element which is less than 34. So now I will remain static and J will move one element further, which is 17, and it will check whether J is less than 34 or not. If not, then it will stop over here, correct? And I is less than a pivot or not. If not, then it will also stop over here. Okay, so J will check if it is greater than 34 or not, and I will check if it is greater than 34 or not. Now in this scenario, 40 and 17 now are meeting the condition that whether 40 is greater than 34 and 17 is less than 34, we will make a swap of these elements. So 17 will interchange with 40 and 40 will interchange with 17, and then now I and j will continue their journey ahead. What will happen now? I moves to 21, j is at 40. Okay, now 21 is less than 34, I will continue further. It will come to 8. Okay, 8 is also less than 34. I has now moved to 40. Right? Now 40 is not less than 34. I will stop over here. Now j, what happened with j? J is greater than 34. It will move further. Now j has reached 8 and I has reached 40. Now at this point, when j has crossed I, then now it is the point when you need to swap the pivots. You need to change the pivot. So at this point, when j has crossed, when j is greater than I, you need to swap the pivots. So in this case, what will happen is 40 will get swapped with 34 and 34 will come in place of 40 and 40 will go to the end. Now with this whole exercise, what has happened now, 34 has found its correct position in this entire array. And if you monitor, all the elements on the left hand side of 34 are smaller to 34 and all the elements on the right hand side are greater than 34. And this is what we wanted to achieve. Now the same logic will get applied to left array and right array. In left array now 8 will be assumed as the pivot and in the right array 40 will be taken as the pivot. Now, and applying the same logic, now 8 is taken as the pivot, 17 and 21 I and j are pointing. Now as there are only two elements, 21 is greater than 8, 17 is also greater than 8. So then automatically 21 will move ahead, j will move ahead and I will move ahead, and then 21 and 17 will swap each other. So the final will become 8, 17, 21. Here we only have one element of 51. Okay, 51 and 40 will swap amongst themselves as pivot and they will align themselves. So I know it's a little confusing and a complicated algorithm, but I'll try to explain this with my example. Now what I have to do is I have to create my data and I am creating a quick sort algorithm. Now, in order to start the quick sort, I need to send the 0th index and the length of the array -1. And of course, if the length of left is less than right, means there is some data, then only I'll continue. Now, secondly, what I have to do is I have to find the index of the pivot element and pass it recursively to the quick sort. So now we will create another function which is called partition, which will encapsulate the entire logic. So I'll create my left pointer I, which I was explaining, the right pointer j, which is one less than the rightmost element, which is my pivot, and I'll capture my pivot, which is the rightmost element in our example 34, and then I'll run a while loop for the duration when while I is less than j, right? When j becomes greater than less than I, means when they cross the path, then we will swap the pivot. Now first I will move my left iterator I to the right hand side, right, when it is less than the right, and I'll check my element on the ith index is less than the pivot, because this is my left sub array, and then I'll increment. Similarly, I will move my j iterator from right to left, compare that the element at the j pointer is greater than the pivot. So because I have to create my right sub array. Okay. Now I am checking if my I index is less than j, correct? Then I'll swap the elements, and let me print the array over here. Now outside the while loop, I'll check my array I index is greater than the pivot. Yes. Then I am now changing my pivot, basically pivot value. I'm swapping the pivot value, and I'll print it here for you, and I'll return the I. This is the index of the pivot. Let me indent it correctly and print it. Okay, let's see what has happened. Now this is my original array where the pivot is starting from 34. Now, as I told, my I did not move ahead because I is checking if my element of I is less than pivot. 40 is greater 40, so I has not moved, but j moved. J moved from started from 51 till 71 till 17, and it stopped over here. And at this point 17 and 40 got swapped. 17 came over here and 40 came over here. Now hereafter I started moving forward. 21 is less than 34. Okay. 8 is less than 34. Okay. 40 is less than 34. No. So I stopped over here. My j was at 40. It moved further. 8 is greater than 34. No. So I and j have crossed each other. Now this is the point where we have to make a swap between 40 and 34. Okay. So 40 will move to the end and 34 will come in middle. So now 34 has reached its desired and actual position, and all elements left of 34 are smaller than it and right of 34 are greater than it. Now I am working on my left sub array where 8 is my pivot. Now I will start from here. So 17, it is greater than 8, it will not move ahead. 21, it is greater than 8, it moved ahead. J, and it reached 17. Now 17 and 21, now j has crossed I, they will swap each other. Okay. And now my array position is 8, 21, 17, 34, 51, 40. Now my pivot changes to 17. 17 will be compared to 21, and this is the swap happening over here. Now coming to the right sub array, my pivot is 40, only single element is there, 40 and 51. The swap will happen over here. So as you understand quick sort, you will better understand when you run it with multiple examples. So I hope you had a great learning session on these sorting techniques and you will be able to apply them in your regular programming on Python. Thanks for watching the video. I look forward to meeting you in my next session. Thank you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.